start a new chapter called Multivariable Calculus of Partial Differentiation and its Applications. First, we should understand what is a multivariable function. If the function is having more than one variable is called as multivariable function. If we take an example, z is a function of x square y plus 2x. So it is a function with variables x and y. Now the dou z by dou x is equals to, it means we are differentiating the function z with respect to x. So when we are differentiating the function with respect to x, other variable is treated as constant. So here this term is differentiated with respect to x. Nothing but the other variable y is treated as constant. So write the y as it is. Then differentiation of x square with respect to x is 2x plus 2x differentiation with respect to x is 2. So this is the dou z by dou x. Then dou z by dou y is equals to differentiating the function z with respect to y. Then other variable x is treated as constant. So write x square as it is here. And the differentiation of y with respect to y is 1. Plus 2x is differentiated with respect to y. As there is no y variable in this term, then the whole differentiation becomes 0. So this is what dou z by dou y. Then on multivariable function, we have to use partial differentiation. Then here let z is equals to a function with variables x and y. So f of x comma y, it means the function is having the two variables as x and y. Let it be a function of two variables x and y. Then the partial differentiation or partial derivative of z with respect to x is denoted as dou z by dou x, or you can even write it as dou f by dou x, or you can write it as f of x. So here let z is a function with variables x and y, and then the partial derivative of z means differentiation of this z variable with respect to x is denoted as dou z by dou x. It means the function z is derivated with respect to x. You can write it as dou f by dou x or fx. Then the partial differentiation of z with respect to y is denoted as dou z by dou y. It means the function z is derivated with respect to y, or you can write it as dou f by dou y or fy. So this is what derivation of z with respect to y variable. Then so in this case the other variable is treated as constant. It means when we are derivating a function with respect to y, the other variable, it means if the variable is x, then that x is treated as constant. Then here when it is derivated with respect to x, other variable is treated as constant. This is what this statement says. Let's understand here the second order partial derivatives. Second order partial derivatives are dou square z by dou x square and dou square z by dou y square, dou square z by dou x dou y, dou square z by dou y dou x. So these four are the second order partial derivatives. Here z is a function and that function is consist of two variables x and y. So this comes the second order partial derivatives, nothing but whose order of the derivative is 2. It means the function is derivated 2 times. So here dou square z by dou x square can also be written as dou by dou x of dou z by dou x. So at first z function is derivated with respect to x, that gives dou z by dou x. Again differentiating with respect to x, it means this is treated as one another function and this function is differentiated with respect to x, that gives a second order partial derivative, that is dou square z by dou x square. Similarly dou square z by dou y square is nothing but dou by dou y of dou z by dou y. It means this function is derivated one more time and that gives a second order partial derivative. Then dou square z by dou x dou y, that equals to dou by dou x of dou z by dou y. Dou z by dou y is now differentiated with respect to x. And then dou square z by dou y dou x can be written as dou by dou y of dou z by dou x. So at first the differentiation is again differentiated with respect to x, and next dou z by dou y is differentiated with respect to y, and then dou z by dou y is differentiated with respect to x, and then dou z by dou x is differentiated with respect to y. So these four are the second order partial derivatives. Discuss one problem here. Find the first order and second order partial derivatives of the function ax square plus 2hxy plus by square, and thereafter verify that dou square f by dou x dou y is equals to dou square f by dou y dou x. So here find the first order and second order partial derivatives. It means differentiation of z. If we treated this function as z, then that z should be differentiated with respect to x and y, that gives the first order, and when we differentiate them one more time you get the second order partial derivative, and at last you have to verify this condition. Let f is equals to, let f is the function ax square plus 2hxy plus by square, then partial derivative or partial differentiate with respect to x in equation 1. So let this be as equation 1, and we have to derivate this equation with respect to x, that is dou f by dou x is equals to dou by dou x of, write the function here f, write the function, that is x square plus 2hxy plus by square. So this is what f, and differentiating this function with respect to x. So now for more clear, if we write, so this each term is differentiated with respect to x. So for better understanding, write the differentiative term for each term as dou by dou x of ax square plus dou by dou x of 2hxy plus dou by dou x of by square. So now dou f by dou x is equals to, so here x square is differentiated with respect to x. A is a constant. So differentiation of x square is 2x. So a into differentiation of x square is 2x plus dou by dou x of 2hxy. So 2h is a constant, right? Constant as it is, and xy is derivated with respect to x. So when xy is derivated with respect to x, as I told you, other variable has to be constant. So here other variable nothing but the variable y. So y is treated as constant. So write the y as it is here. And then derivative of x with respect to x becomes 1 plus dou by dou x of by square. So here we are derivating with respect to x. As there is no x term in this, x variable in this term, then the whole differentiation becomes 0. So at finally it gives dou f by dou x is equals to 2ax plus 2hy is the differentiation of the function f with respect to x. Then here similarly partial differentiate with respect to y of equation 1. Partial differentiate with respect to y of equation 1, that is dou f by dou y is equals to dou by dou y of the function is ax square plus 2hxy plus by square is a function. Now this function is derivated with respect to y. So for more clear, write here dou by dou y of ax square plus dou by dou y of 2hxy plus dou by dou y of by square. Then here dou f by dou y is equals to, so ax square is differentiated with respect to y. As there is no y variable in this term, then the whole differentiation becomes 0. Then plus dou by dou y of 2hxy. 2h is a constant as it is, and then xy is derivated with respect to y. So when we are derivating with respect to y, other variable is treated as constant. Then here other variable nothing but x. X is treated as constant. So write x as it is. And then y is differentiated with respect to y, that gives 1 plus dou by dou y of by square. So b is a constant, write b constant as it is. And y square is differentiated with respect to y, and its derivative comes as 2y. So dou f by dou y is equals to 2hx plus 2by is the differentiation of the function f with respect to y. So as they told to find the first order, so we have find out the first order for x and y. Now furthermore we have to find the second order partial derivative. So second order partial derivative comes as dou square f by dou x square. So this is the second order partial derivative we know, and this nothing but dou by dou x of dou f by dou x. So dou f by dou x is differentiated again with respect to x to get the second order partial derivative with respect to x. So here dou square f by dou x square is equals to dou by dou x of, and dou f by dou x we got it as 2ax plus 2hy. This was the dou f by dou x. So here now dou square f by dou x square is equals to dou by dou x of 2ax plus dou by dou x of 2hy. Then here dou square f by dou x square is equals to 2ax is differentiated with respect to x, and 2a is a constant, write 2a as it is, and x is derivated with respect to x, that gives 1 plus 2hy is differentiated with respect to x. As there is no x variable in this term, then the whole differentiation becomes 0. So here dou square f by dou x square is equals to 2a. So this is the second order partial derivative of the function with respect to x, gives the 2a. Now similarly find the second order partial derivative with respect to y, that is dou square f by dou y square is equals to dou by dou y of dou f by dou y. This gives the second order partial derivative with respect to y. Then here dou square f by dou y square is equals to dou by dou y of the here we got it as dou f by dou y is 2hx plus 2by. That is 2hx plus 2by. And now here dou square f by dou y square is equals to dou by dou y of 2hx plus dou by dou y of 2by. Then that equals to dou square f by dou y square is equals to 2hx is derivated with respect to y. As there is no y term in this y variable in this term, then the whole differentiation becomes 0. So its derivative is 0 plus 2by is derivated with respect to y. Write 2b as it is, as it is a constant, and y is differentiated with respect to y, that gives 1. Then here dou square f by dou y square is equals to 2b is the answer. So when we differentiate a function with respect to y for the 2 times, we get the 2b as it is a second order partial derivative with respect to y. So we have found out the first order partial derivative and second order partial derivative. Now it comes to the verification part. We have to verify that dou square f by dou x dou y is equals to dou square f by dou y dou x. So we have to prove this condition. For that you need to find the dou square f by dou x dou y and dou square f by dou y dou x. So find them. Dou square f by dou x dou y is equals to, we know that dou by dou x of dou f by dou y. So dou f by dou y is derivated with respect to x, and that gives the dou square f by dou x dou y. So that is dou square f by dou x dou y is equals to dou by dou x of, and dou f by dou y we got it as 2by plus 2hx. Now differentiate this with respect to x. Dou square f by dou x dou y is equals to dou by dou x of 2by plus dou by dou x of 2hx. Then dou square f by dou x dou y is equals to 2by is differentiated with respect to x. As there is no x variable in this term, then whole differentiation becomes 0 plus dou by dou x of 2hx. 2h is x is differentiated with respect to x. 2h is a constant at 2h as it is, and x is differentiated with respect to x, then that gives 1. Then here dou square f by dou x dou y is equals to 2h. Let this be as equation number 2. Then we have here similarly dou square f by dou y dou x is equals to dou by dou y of dou f by dou x. Now dou f by dou x is differentiated with respect to y. That is dou square f by dou y dou x is equals to dou by dou y of dou f by dou x, we got it as 2ax plus 2hy. Now this is differentiated with respect to y. Then dou square f by dou y dou x is equals to dou by dou y of 2ax plus dou by dou y of 2hy. Then that gives dou square f by dou y dou x is equals to differentiation of 2ax with respect to y. As there is no y variable in this term, whole differentiation becomes 0 plus 2hy is differentiated with respect to y, then 2h as write it as constant, then y is differentiated with respect to y, that gives 1. Then dou square f by dou y dou x is equals to 2h. Let this be as equation number 3. So from 2 and 3 we can write it as dou square f by dou y dou x dou y is equals to dou square f by dou y dou x, as because dou square f by dou x dou y is equals to 2h, and also dou square f by dou y dou x is also equals to 2h. So from these both equations we can tell these two are equal. Then it comes as dou square f by dou x dou y is equals to dou square f by dou y dou x. Hence verified. So first we have find out the first order derivatives. Then after we have find out the second order partial derivatives. So to find the second order partial derivatives, you must find the first order partial derivatives, and after getting the first order derivatives, differentiate them again, you will get the second order partial derivatives. Then it comes to the verification. That verification, just differentiate them and equate them. That gives the verification part. Thank you.